Good day, everyone. My name is Graham Ward, and on behalf of SpaceX Cruise Lines, I would like to thank you for coming to the data science team's proposal for a predictive model to support the new rescue pod operation program. Our Chief Data Officer, Brian Hardigan, assembled this team of 3 data scientists for this project, and together we have over 100 years of data science experience across the various domains of aerospace engineering, astrophysics, economics, intergalactic meteorology, and intergalactic data relay networks. We're excited to help provide affordable, safe, and luxurious intergalactic travel.
Hi, everybody. This is Tanya here. I am a data scientist here at SpaceX Cruise Lines.
SpaceX Cruise Lines is a subsidiary of its parent company SpaceX, which was founded in 2002 and has been an industry leader in space technologies, intergalactic communications, and intergalactic shipping. Much of SpaceX's success in this industry comes from its continued leadership by visionary Elon Musk, who continues to lead the company after making advances in biomedicine and neural network uplinks. SpaceX Cruise Lines aims to capture a market share for intergalactic travel through being an industry leader. Currently, there are no other entities operating within this market across any other habitable planet. And with over 50 habitable worlds requiring transportation, the profit potential is monumental and quite difficult to fully capture. The rescue pod operation program itself arose from the need to ensure the safety of all passengers and crew in the event of an encounter with space-time anomalies, which subsequently cause seemingly random transportation of some passengers outside the bounds of the ship. SpaceX Cruise Lines was founded in the year 2850, and after 10 years of legislation, licensing, and funding rounds, construction began on the spaceship Titanic and the Warp Speed Data Relay Network. In the year 2880, the Warp Speed Data Relay Network finished construction, and the testing of intergalactic messaging took 20 years to validate. In the year 2910, construction on the spaceship Titanic concluded, and it successfully completed test flights of Earth's solar system. Then in the year 2912, the spaceship Titanic performed its maiden intergalactic voyage and encountered a space-time anomaly, displacing passengers and requiring rescue teams be deployed. In the year 2912, the spaceship Titanic had an unexpected collision with a space-time anomaly on its maiden voyage after rounding the edge of the Alpha Centauri star system. This collision caused 49% of the passengers on board to be transported to another dimension. Thankfully, the Warp Speed Data Relay Network alerted rescue teams across different planets in the galaxy, and we were able to safely recover 100% of the passengers affected. However, during the AAR, the necessity for a predictive model to identify those passengers at risk for being transported in the chance of another event became apparent and utterly necessary. The goal of the predictive model will be to identify these passengers and prepare the appropriate number of rescue pods to be ready at any given time to immediately transport to the affected individual's four-dimensional location and bring them back safely within 1 minute or less.
Now let's discuss the key constraints and assumptions. First, our data is collected from SpaceX Cruise Lines onboard software, but it's limited to a single event of a ship passing through a space-time anomaly. Additionally, our technology must operate as intended, posing risk if maintenance lapses occur. Next, our rescue pods face challenges, such as limited crew capacity, manual activation for some rescues. We must also plan for scenarios where rescue crews themselves are transported, requiring reconfigured crew spaces. In risk management, we must also consider incorrect rescue coordinates, inadequate rescue pods, and necessary redesigns. Lastly, we must propose using dual protective braces and recovery kits for passengers. These enhancements will protect them from warping, unfriendly atmospheres, and vacuum conditions until rescue. We can conclude that these constraints and assumptions will help us refine our approach, ensuring safety and efficiency in our intergalactic travel services. Now let's review the key considerations. First, predictive analytics can revolutionize our approach by developing algorithms to predict which passengers might be transported by anomalies. The proactive preparation enhances passenger safety, a core objective of SpaceX. We need to analyze the trade offs between the high cost of traditional rescues and investments in predictive technology. We can both save lives and expenses, we can improve efficiency and reduce liabilities, aligning with our goals. Lastly, enhanced safety measures can lead to improved market reputation and financial performance. This positions SpaceX as a leader in the safe space travel, attracting more customers and investors. Now let's explore some key data insights on transported passengers by cryosleep status and destination. On the left, we have non-cryos passengers are transported more often with over 3,500 versus those 2,000 in cryosleep. This suggests cryosleep might reduce transportation likelihood. On the right, we have destinations analysis. TRAPPIST-1E has the highest transported passengers at over 5,600 with few VIPs. PSO J318 and Concrete E have fewer transported passengers based on their destination. Finally, we can conclude that passengers not in cryosleep and those heading to TRAPPIST-1E are more likely to be transported. These insights help us refine our predictive models and enhance our passenger safety.
Hello, my name is Jun, the third data scientist on the team. I will be outlining our evaluation process for model development. We start by creating an initial model using a nearest neighbor algorithm. Next, we will analyze the model's performance, specifically looking at the area under the curve metric. Our goal is to achieve an AUC of 0.95 or higher. If that criteria is not met, we will evaluate our approach by analyzing our feature selections, training and modeling using other nearest neighbor algorithms to update the model. This cycle of creation, evaluation, and adjustment will continue until we reach our target AUC of 0.95 or above. Our business goal is focused on developing dedicated, customizable rescue pods. By leveraging our predictive model, we can identify passengers likely to be transported by the space-time anomaly and have rescue pods ready on standby. Our objective is to ensure that 95% of transported passengers are returned within 1 minute and that all passengers are safely returned within 5 minutes. This rapid response capability will significantly enhance passenger safety and satisfaction. For this project, we are initially allocating 2 to 4 billion Earth dollars to build custom equipment and develop our dimensional transport prediction algorithm. Once this initial phase is successfully completed, we will move on to the overall project, which is estimated to cost between 27 and 50 billion Earth dollars. This phase will cover the manufacturing and production of the pods, as well as the development of advanced AI for navigation and dimensional travel algorithms. Our comprehensive budget plan ensures that we can effectively and efficiently achieve our goal of rapid passenger retrieval. As we conclude our presentation, it's important to highlight that our project ensures that all transported customers are returned within 5 minutes. This achievement will significantly enhance customer satisfaction and safety, leading to a positive impact on our company's market value and reputation. Looking ahead, the predictive algorithm developed in this project will enable us to design next generation cruise liners that are unaffected by space time anomalies. This innovation will drastically reduce our rescue budget and solidify our position as the number one company for the safest intergalactic travel throughout the universe. Thank you.